Should we start? 5 past? Can you please go to Menti and enter the code to access the slides? And it's, as usual, it's going to be an interactive lecture, but it will not allow to ask questions, because last time there was apparently basically didn't go well with some students who emailed me saying that it was just this, what do you call this, wasn't good for them to see the silly questions being asked, or it just disturbed them, or distracted them, I should say. So it just was distractive rather than productive for them and for me. So I decided to disable the questionnaire. So you can ask any questions that you have from today during the seminar classes. So hold on to them, yeah, or just jot down, or just come see me after the class, after these lectures, if you have questions. Yeah, I would like to take questions from you if you raise your hand, and if you can speak louder, yes, why not to ask as well. So markets in action, today's topic. It's about the elasticity of demand and supply and other measures of elasticity. Now, the reading is required here again. It will be a topic tested in your assignments rigorously. In other words, there will be several questions on this topic, multiple choice type question plus a numerical type question. Yeah, so you have to do some calculations as well. And the calculations are basic, not much. It won't require more than the GCSE level math here. Maybe some practice. So we'll do this. We'll practice this in the problem sets that will come next week. Learning objectives are listed there. I just do not want to sort of go over them, but we will cover all these points, focusing more on the elasticity and calculations and the applications in economics and in business, obviously. Right, what is an elasticity? It's a measure of how much a buyer or seller responds to changes in market conditions. Or in other words, it's the if you want to understand in plain language, it's basically reaction of buyers and sellers to changes in the market. It could be a change in quantity supply, change in prices, for example. Yeah. So we'll start with demand elasticity, and we'll focus on demand elasticity throughout the lecture. You will be able to read about supply elasticity in the textbook. The concepts that we studied today, the methodology, the calculations will be very, very similar to supply. So the supply and demand elasticities in terms of concepts and factors that affect them is quite similar, and formulas are not different either. So we will focus on demand elasticity and its application, and then move on to income elasticity and cross-price elasticity today. Right, so price elasticity of demand, as you can see, it's basically the percentage change in quantity demanded when price changes by a certain percentage, for example, by, let's say, 1 percentage point. And the formula here is shown here is just a ratio of percentage change in quantity over a percentage change in price. In simple words, basically this formula measures the sensitivity of demand to changes in price. Moving on, there are two types of elasticities. We'll focus on one, arc price elasticity only. We will not look at a point elasticity of demand. You can read about it in the book, but I kind of decided to look at only specific aspects of price elasticity, such that it will be easier for you when it comes to exam time, so you don't confuse between the concepts of elasticity and formulas. So we'll stick to one method of calculating elasticity, and we will just use it in our assessments as well. Now, there was a question, by the way, there's a little digression here, that you have presented certain topics and concepts in the lecture, but then when I opened the book, there are more concepts to read. Yes, focus on the lecture material. They will certainly be a part of the assessment and part of your learning that can be carried forward to next year. But then next year you may have you may want to do a managerial economics. Then reading the whole chapter helps, and being able, understanding it helps as well, because you want to go and do an internship in the city of London or somewhere else after your second year, maybe after your first year even, yeah, summer internship. Then you want to be confident in your abilities to understand the commercial activities or economy, yeah, that's or the economic activity that's taking place right now in the UK. So reading the chapters fully will help. Yeah, please read them. Some questions may be concepts that are not covered in the lecture, but they are in the books. So nothing comes outside the book in the assessments and in the lectures, but there are more concepts and topics to cover in the book than in the lecture. Given that we have 1 hour, I will focus on the main learning objectives. Yeah? So learning objectives sometimes are wider, but they will focus on the main key elements of learning objectives. So this, for example, I'm looking at arc price elasticity right now instead of point elasticity, because this measure is better in terms of measuring or sensitivity of quantity demand and supply to price changes than the point elasticity. And the difference is explained in the book in more details as well. Now, focusing on price elasticity of demand, it basically measures the elasticity over a discrete interval of demand. Yeah. So look at this. This is a very complicated looking, but it's very easy formula. It's basically the percentage change in quantity here. Notice this. Quantity 2 is a new quantity. Quantity 1 is an old quantity. In the denominator, you have an average. Quantity 1, old quantity, plus quantity 2, new quantity, over 2. This is just an average value. And the whole ratio here, whole fraction here, measures the percentage change. So instead of having Q1 here, we just have an average. So a change in quantity over an average, or midpoint, is just percentage change in quantity. Now, divided by a price change over midpoint of prices. So there's a new price and an old price added, divided by 2 gives us average. So this is just a percentage change in price. So essentially, the arc price elasticity is basically a percentage change in quantity over a percentage change in price. And we will look at the numerical examples here in a minute. So moving on now. So here is the graph of what we've just described. Take a look at the graph. Here in this case, for example, price changes from P1 to P2. This leads to a reduction in quantity demanded from Q2 to Q1. This may be a little confusing because the labeling here is wrong. So this has to be Q1 instead of Q2. Yeah? But ignore it for now. So it simply shows you that when the price changes by this much, there's a reduction in quantity by that much. So we're just trying to now measure the sensitivity of quantity change here to the changes in price in this case. So this is just graphical representation of this formula here, right? So it becomes a little clearer as we move on now. So right now it may be abstract. Let's move on now and give an example using a straight line demand curve. As you can see, this is a perfectly downward sloping demand, and remember that demand curves are downward sloping because as the prices rise, quantity demanded declines. Now in this example, I have rewritten the arc elasticity. So let's get rid of that. Whoops, I didn't mean to do that. Apologies. Yeah, it seems to be getting in the way here. Maybe doesn't help now. So this is basically measuring elasticity using the arc method here. So this formula is the arc method formula. As you can see, change in quantity is basically nothing but just change in the difference between the new quantity and old quantity here. Yeah. So that's delta Q is just the change in quantity over the midpoint. Midpoint of Q is average of the Q. If I go back again to show you what I mean, is this point here. Yeah, Q1 plus Q2 over 2 is just a midpoint here. It gives us one number, it's a value between Q1 and Q2. So in this case, it will be a quantity right here, right in the middle here. Yeah, and then midpoint P will be this point here. Yeah, so going back, so that mid P is basically average P, and delta P is just P2, which is the new quantity, a new price minus the old price. Now, this is just a ratio on its own. Yeah, so percentage change in quantity over percentage change in price. Now, looking at this example here, notice that delta P is negative. Change in price is negative. That means we have a new lower price. Price declined. So price declined from 8 to 6 pounds. So that delta P is negative. And when the price declines from this point to this point, as you can see, there's a movement along the demand curve to point N from point M. So that's an increase in demand from 10 to 20. As a result, quantity change is, as you can see, quantity demand change is positive 10. So now we have the prices and then quantities. You can now work out what the average is. So midpoint P is 7. That's basically 6 plus 8 divided by 2 is right here. It's the 7. So it's midpoint between 6 and 7. And similarly, midpoint Q is basically 15 here. Yeah? Average value of 10 and 20. That's 10 plus 20 over 2 is basically 15. Now moving on now, what's the result now? So we plug in the numbers that we've just calculated. So delta Q is 10, midpoint Q is 15 over delta P is minus 2, midpoint P is 7. So a bit of arithmetics here, and then you have a negative 2.33. That is the price elasticity of demand. That implies basically 1%. So this is important. 1% increase in price, 1% increase in price results in 2.33% decrease in quantity demanded. Yeah, 1% increase in price gives us a negative value, so it's a decline. Yeah, 2.33% decrease in quantity demanded. In other words, I'll describe this in a minute. This product has a elastic demand. What it means is that reaction is stronger than to the price changes than we expected maybe. Yeah? So certain products like luxury products usually have this. When their prices go up, we stop buying them. The things that are a necessity, let's say, not like this Adidas and Nike and things like that. We still buy them. Obviously, there's an emotional attachment to them. We may like Apple products. We keep buying them. Even if the prices are high, we still see 3-day queues for certain products. But there are products for which reaction is far stronger to the change in prices. Yeah? A 1% change in this case gives us a 2.33% decrease in demand. So sales go down by that amount when the price goes up by 1 percentage point. Yeah? Well, the opposite is true as well. When the prices go down, the demand increases by that much. So you can talk of the reciprocal as well. Now, elasticities usually are values between certain ranges. In this case, let's look at the common cases, for example. So if the elasticity of demand with respect to price, EP, in this case, is greater than 1, notice that I put modulus. Modulus means whatever inside it comes out as positive value, yeah? So usually demand elasticities are negative, but we just ignore the sign. Because we all know that demand is downward sloping, so elasticity of it will also be negative. But we're ignoring the sign, in other words, in modulus, EP, if it's greater than 1, we say that the demand is relatively elastic. In other words, to a 1 percentage point change in price, there is a greater change in quantity demanded, greater decline in quantity demanded, in other words. So the reaction is stronger. Now, if the elasticity is EP, in this case, yeah, EP, is between 0 and 1, in other words, less than 1, but greater than 0, in modulus, remember, this is, we're looking at the positive values, just the magnitude. We say that the elasticity is, or demand is inelastic, or the good is inelastically demanded. So these goods are, you keep buying them even the price goes up. These are necessities usually, aren't they? Yeah, or the products that have lower price and higher increase in prices do not actually affect our budget much. So we keep buying them like bread. We have to buy them, we have to eat them, water, eggs, things that are necessity. For them, we have inelastic demand. We need them to survive as well. So there are different ways of looking at them. But so essentially, keep in mind that inelastic demand is when the sensitivity of that demand or price elasticity of that is actually between 0 and 1. Now, you have a unitary elastic demand as well. That's just when 1% change in price leads to 1% change in demand and supply. That just, there's no kind of underreaction or overreaction to these changes. Yeah. So exactly 1-to-1 change. Right? So there are extreme cases like you studied correlation in your A-levels or B.Tech or some other courses, that correlation has perfect correlation in two extremes. In between lies the actual realistic cases. You know, there is no perfect negative correlation, there is no perfect positive correlation. Similarly, there is no perfectly elastic demand and perfectly inelastic demand. There must be. There might be some imaginary perfectly inelastic case. I'll ask you in a minute. But in rare cases, you may have perfectly elastic cases as well. In these cases, EP will be either infinity, in other words, very large change in quantity demanded when the price changes slightly. So that's infinity. It's a very large number, so we don't describe them. We just say quantity demanded is infinite when the price changes. So there's a perfect elasticity. Now, perfect inelasticity is when price changes to an extent, there is no demand change. There is no reaction. Even the price goes up by 10%, 20%, price is basically, so quantity demanded is not changing. So zero. Yeah, 0 divided by whatever change is basically 0. Yeah, so if I want to describe this, let's say I need to just go back. So we're looking at price inelasticity in this case. Yeah, so the idea here is this. I'll show you graphically as well in a minute. Basically, price in a perfect inelastic case, price could change by any percentage point, but the quantity doesn't change. So in other words, Q2 and Q1 will be the same. So Q2 minus Q1 being equal gives us 0. Yeah, they are equal. So that 0 divided by whatever this here is basically resulting in a what? A zero elasticity measure. So that's a perfectly inelastic case. Now, these are abstract concepts. I tried to give you examples, but let's look at in graphical representation. Look at a graphical representation and see what we can make sense of them. Perfectly inelastic case, first of all, perfectly inelastic demand, when the elasticity equals 0. As you can see, demand curve is perfectly straight line, vertical line. It's just a vertical. No matter what the price is, or no matter by how much the price changes, we still consume exactly the same amount, 100 units. Think of something in your mind that would have a perfectly inelastic, because then what follows will be a question after this, or maybe after the. Huh? Hold on to that. That's a good one. We'll talk about factors that make products have high or low elasticities. So that medicine is a good example. I may pick that up. Now, moving on to B now. Inelastic demand, or elasticity is less than 1. Notice that the price here, I circled it, price changed by 22%. But reaction is less than 22%. The quantity demanded is 11%. So to a higher change in price, there is a lower change in quantity, relatively low change. These are cases of inelastically demanded goods. So they are kind of necessities. We still buy them. Even if the quantity demanded declined, the extent of decline is not as much as the price increase, yeah? Yeah, so extent is lower here than this, or magnitude in this case. Yeah, so in this case, we have a relatively inelastic demand, looking like this. This is the shape of the demand curve as in that situation. Now, there are 3 more cases before we move on to ask questions. So unit elastic case, you can see that I circled that the 22% and 22% change in both cases. Yeah, the price changes by 22%, quantity changes by 22% as well. So maybe there are rare cases of such things, such products where the quantity demanded just declines by the same percentage point as the price changes. Yeah, so you can think of any examples if you want, but let's move on further. Elastic demand now. As you can see, elastic demand is flatter compared to the inelastic demand. Let's move back. You see this. This is a steeper curve. This is a flatter curve. And notice that the distance here between the new and old quantities is wider than the distance between the new and old prices. So to a small change in price, there is a larger change in quantity demanded. Yeah, the percentage change is larger. So when you take the ratios of these two, you get a larger value as a result. So because quantity demanded is large amount, so 67% divided by 22% gives us a high elasticity value. That's why we say elasticity is greater than 1 here. Yeah, that's an elastically demanded product. Now, on the right extreme or the other extreme, we have perfectly elastic demand, which is perfectly horizontal. At the given price, perfectly horizontal demand curve commands consumption of any quantities. Yeah, slight change in there's a big reaction to quantity demanded. So the infinite change, in other words. Yeah, and there's zero demand or quantity demanded is zero above 4 pounds, 4 euros in this case. Below, basically, if the price goes below, then the quantity demand is infinite. So people buy it. A lot of people buy it. Think of it that way. But it's a very, very abstract concept. So that the things in between the two cases make sense. It's like correlation. Like as you have two variables, and in real life, two variables do not perfectly correlate with each other, right? Or do they? The only time you can see perfect correlation is when you correlate something by itself. But then in real life, there's could be near perfect correlation, but nothing is exactly 1 or 100% correlated, yeah? So it's the same case here. You have two conceptually sort of theoretical cases. In between lies realistic cases. So realistic cases are this here, this case here, and this case. And this is less realistic. This is possible if you live on Mars. There's a question to you guys, and answer by entering this code. Please answer it, please. And we'll see your answers right in this box. And you have to type your answers, and please do not type things that we don't want to see. So name a product, service for which demand is perfectly inelastic with respect to price. Milk. Interesting. Petrol, water purification. If the answer that you want to type is already displayed here, try not to type it so that we don't overcrowd the screen. Yeah, let's not have water. There's a lot of water here going, so let's not have it. And bread as well, or milk is already there. Please do not type milk or petrol or whatever it is. Eggs, you don't. This is interesting. Eggs. No. Toothpaste. Cigarette. That makes sense. Cigarette. Yeah. Right. So 55 of you answered, and more. Bags. Water, insulin, interesting. Yeah, they're individual cases. So we're looking at the general case for everyone, that applies to everyone. But yes, in some cases there must be individual cases that medicine does appear to be because it's a life and death case, isn't it? Insulin does appear to have inelastic demand, perfectly inelastic demand, maybe if there is no substitute. Mad. So I can see in general, I can group them into food or addiction, emergency medicines, phones. So you don't know, you know what, alcohol is there. In perfect elastic case, inelastic cases, basically product is a necessity. Without it, you cannot live. The product is a necessity. Without it, you cannot live. So you need to think about that sort of product, that imaginary product you may have in mind, or a product that already exists. Toothbrush, and okay, all right, so it's too much now. Now, moving on, I'll talk about it. So there are things that we do not probably see. You know, if you live on Mars, and Elon Musk wants it possible in about a couple of years' time, and you see space tourism is booming, and let's say if you're living on Mars, your demand for oxygen is inelastic, perfectly inelastic. And the only way we can take or provide the oxygen on Mars is by delivering it in a spaceship. So it comes from Earth, right? Oxygen. So that is probably, if space tourism becomes a commercially viable product and living on Mars becomes a realistic case, then we will end up having a perfectly inelastic product on Mars. Yeah, and we need it, and we will be able to, and we are happy to pay any money, any price, if we are there. Yeah, we will be promising, give me the thing, the oxygen tank, I will pay you anything when I get back on Earth. Yeah, so this is the case. That's the only thing I can think of, or water can be. Yeah? But we have to imagine to be able to come up with this perfect cases, and that's why I'm telling you, perfect cases do not necessarily exist. In between, they do. in between the values, or the cases in between may. Now, what affects the demand elasticity? What makes some products so inelastically demanded? First of is the ease of substitution. If you can substitute products, let's say water, some of you said it's perfectly demanded, perfectly inelastically demanded. Possibly, but water can have a substitute. You can eat watery, juicy fruits. Yeah, there could be possible substitutes. Cucumbers, yeah, or apples, to quench your thirst. They are substitutes. That's why they are inelastically demanded, but not perfectly. But air, oxygen, doesn't have a replacement, right? So substitution. Or if a product is necessity or luxury, necessity products usually command inelastic demand, while luxury is elastic demand. Even the super rich will not buy certain products because they are so expensive. Right? They don't want to buy it basically because the prices are high. Yeah? Then the price go up. So luxury is even command. Luxury is basic command high elasticity demands. Now proportional total expenditure. So some products we buy them because they're quite cheap, even if the price goes up by 100%. If something is £1 and it goes up to £2, we still buy them. Yeah. We still, because we spend very small amount of a budget. So if the product is £1,000 and it goes to 1,500, we may give it a second thought before buying it. Yeah. So it's a huge chunk of our budget. So we may not buy. So that also determines how elastically the products are demanded. And length of time. Maybe things that we inelastically demand today in the short run becomes elastically demand in the long run. Yeah, over time. Think of petroleum. In the short run, in let's say a couple of months, we may need petroleum just to drive even if the price is high. So in the short run, petroleum is inelastically demanded. But in the long run, we may then eventually switch to bus or public transport or buy an electric car. Yeah. So the length of time also determines the demand for demand elasticity of cars, and durability of products. Certain products are quite durable. We can fix them, repair them, and we can delay the purchase of them. Yeah. If the prices go up, as a result, they also become elastic. While they might be inelastic initially, but then because they are durable, we can reuse them or buy them from a secondary market. Yeah, or second-hand market. Sorry. So these are important factors that determine elasticity. Now, there's a special relationship or interesting relationship between price and revenue. So I should say elasticity, total revenue and elasticity. Think of this case here. This is the demand curve, downward sloping. As the price rises, quantity demanded decreases. Now, at this point, let's say price is £2, and this person demands 3 million units per period of time, or maybe this in the market. Then the expenditure in the market is basically price times the quantity demanded. So price times the quantity demanded gives us 6 million. So if we sell this product at this price, £2, this area then represents the total expenditure if we are looking at the consumer side. But if you're looking at the producer side, that area is firm's total revenue as well, price times quantity demanded, yeah? So 2 times 3. Makes sense? Right, moving on. So we're trying to describe the special case here. Notice this first case. It's a little blurry, but hopefully you will be able to see. This is basically saying expenditure falls as price rises. You should be able to see it, yeah. Right, so this, as you can see, this curve is, demand curve is relatively elastic. We say demand is relatively elastic in this case. And notice that we will increase the price from £4 to £5. What happened is that initially with the £4, the demand was 20 units. But when the price went up to £5, demand came down to £10. Now, revenue initially was 4 times 20 millions of units, yeah? So that is this whole area. But when the price was increased, what happened is that there was a larger reaction. Remember, this is elastic demand. So there's a large reaction to a small change in price. As a result, we started selling 10 millions now at £5. Now, this area now is our, or pinkish area is now our revenue, total revenue. Notice this is just 50 million. Now it was 80 million before. Now what happened is that because of price rise, quantity demanded shrank. As a result, we lost this area. This is the total revenue we lost with the new price. And then we gained this area, this brighter pink area, as a result of price change. So, which then tells you that if you have a product that has an elastic demand, you should not increase your price because your losses as a result, total revenue losses are higher. Now look at the second case now. This is a relatively inelastic demand, steeper demand, and you can see that the originally the price was £4 here, and we doubled the price. We doubled here. In this first case, there was a £1 increase, one pounding, but here we doubled it. But the reaction was less than half demanded, yeah? Or more than half. I mean, originally the quantity demanded actually declined by 100% here. Yeah, halved basically. But here that reaction wasn't observed here because we have an inelastic demand here. So from the price rise, we gained a larger area that shows us a higher revenue than what we lost. So the difference between here is basically what we gained essentially, right? So notice that this gives us a conclusion that if you have a product that is inelastically demanded, you can increase the price to increase your total revenue. But if your product is elastically demanded, as a business owner, you should double think or think twice before increasing your price. Yeah, you can always find out about these things by experimenting with your products, by raising it for a week and taking a tally of the quantities sold and then putting the price back for a week again, looking at the quantities and see what the reaction is, yeah, if you are a business owner right now or later on, yeah. So elasticities do affect the total revenue, as a result, the total profit of a business as well. Now, this nice table here just summarizes these ideas that we just described. So when the demand is elastic, increasing the prices leads to total revenue declines, yeah? The arrow shows that the total revenue goes down. But decreasing it increases the total revenue up. So when you have actually a highly elastic demand, we should actually reduce the price rather than increasing. Because we may reduce the price, we may lose a few pounds on each product we sold. But then in total, in general, we actually earn more total revenue apparently, yeah? If you want to increase revenue, increase your total, reduce your prices. In unit elasticity cases, you just get exactly the same changes. So nothing changes. It will be exactly the same increase or decrease in total revenue as an increase in prices, yeah? But in elastic cases, notice that when you have if the demand is inelastic like this here, then price increases lead to greater increase in total revenue. So we should be increasing our prices if we want to increase our total revenue. However, we shouldn't reduce our prices because it's a necessity, let's say, yeah? We don't expect the people to buy 10 loaves of bread if we reduce the price by half. Yeah, people buy what they need if it's a necessity. We don't expect people to buy 10 kilos of salt if we reduce the price of salt by, let's say, 50%, yeah? Even if we increase by a certain amount, they will continue buying more or less the same amount of quantities demanded. Elasticities usually are, inelastic goods are usually quite robust to changes in prices in terms of price rises, I should say. Okay, so we'll summarize this thing with a graph one more time before we move on to another concept. So straight line demand, this is something that I have not introduced yet. Notice that, look at the first graph first. The y-axis here is price of a product. Quantity demanded is in the x-axis. Now, in a straight line demand, there is a segment over which, or interval over which, elasticity always is higher than 1, or quantity demanded is demand is elastic, in other words. And there's also a point halfway through. At that point, elasticity is equal to 1, unit elastic. And there's also a segment in this curve where the demand is inelastically demanded, or quantity demand is inelastic. So considering this is a straight line case. We will do an exercise in the problem set next week, and it will be much more detailed. So there I will be able to explain you. Now, look at this now, the relationship between this two cases or three cases and the revenue, total revenue. So this is a graphical explanation of what we just described in that previous slide. Notice now that the y-axis here is total revenue. However, quantities are the same. The bottom line here in this x-axis here, I mean, is the same as this axis here. Notice that as we move along downwards, the elastic part of the demand curve, as we sell, as we reduce the price, quantity demanded increases, yeah? And total revenue, however, increases too. Notice that total revenue goes up. So this revenue curve is going up. At some point, total revenue peaks. We don't earn more than that point, more than that amount. And that's when we reach the demand point, a point on the demand curve which has an elasticity equal to 1. Yeah, that's the peak. Beyond that part, remember, this segment is basically inelastic demanded segment. So demand is inelastic in this case. As a result, reducing the price further doesn't make sense because it actually reduces our total profit, or total revenue, I should say, sorry. Yeah? So we shouldn't reduce our, as a result, we shouldn't reduce as a business owner our prices if we have inelastic demanded product. It's already inelastic demanded, so why should you reduce it? Because people will still buy it at a high price, yeah? That's the idea. And so this nicely explains us the concepts that we described in this slide. Moving back, yeah? This part here, this table that just describes whatever we just looked at in this part here. So, moving on. Examples. Coffee is what we consume day to day. Notice the elasticity. Ignore the sign, minus sign. It's always negative for demand elasticity. But look at the magnitude. 0.2, it's between 0 and 1. It's highly inelastically demanded. So we have addiction to coffee. In the short run, for addiction, products that we tend to addict to will usually command high inelasticity. Yeah, we inelastically demand them. We need them because this is what the blood wants, or what the organism wants. Our health depends on them, maybe. But in the long run, we tend to find new substitutes. So elasticity increases a bit, but it's still inelastically demanded. So coffee looks like it, always inelastically demanded. The addicts will, when I'm saying addicts, are coffee lovers, I should say. Don't get offended. So coffee lovers will always want to have the coffee. They don't want to substitute it. So some of us, not all of us, apparently will just switch. Because of that, there is a little bit higher elasticity. But otherwise, it's just still inelastic demand. Kitchen and household appliances, so the ladies know this. They really need them to run the kitchen, let's say, yeah? It's always inelastically demanded. Meals at restaurants makes sense. If the restaurant meals are expensive, we tend to not go there if the price go up, yeah? We would rather cook at home. There's always a very good substitute for restaurant meals at home. Airline travels makes sense. We quickly switch to train or public transport to travel from cities to cities, yeah, between cities. So there is elastic demand. So 1.98 is a huge response. Basically, 1% increase in airline tickets is leading to almost 2% decline in airline ticket sales. Oh, U.S. oil demand. Now, U.S. is gas guzzler country. People like driving cars there. They like even driving bigger cars, which are very oil-intensive, oil-consuming cars. And notice that it's almost zero. It's perfectly inelastic demand for gasoline in the USA. That's interesting in the short run. In other words, in the US, in many states, the public transport virtually doesn't exist. So anyone who lives in countryside or anywhere needs to take the car, drive to city centers to work. So they really need the gasoline, so they rely on gasoline. So in the short run, they're near perfect inelastic demand for gasoline. But then eventually, in the long run, they substitute away some of the driving habits into public transport or other methods. So as such, demand for oil basically is still inelastic, but it's not as low as before. Yeah. So they are substitutes. So here's a quick question for you. 3 minutes. Can you answer it, please? 3 minutes. We don't have much time left now. Should the firm raise the price by 10%? Ultrabook and PC, and their elasticities are given to you. Which one should be raised? Which one should be just recommended by typing? I'll then hide the image after you type. In about 3 minutes, I'll switch. For now, I don't see anyone answering, so think. One answer? 1.5. I assume others are still reading, so I'm going to keep the image there, but I will switch soon. Keep answering. You must see the text box there, and we'll scroll up and down, downwards. Oh, write it down. I'm going to switch now, guys, if you haven't written down. The elasticity is Ultrabook is 1.5. The PC is 0.5. I'm going to switch now. Right. No. PC, yes. Should play games. Raise the PC price and keep the Ultrabook the same. Interesting. What was the Ultrabook? Ultrabook was 1.5. Elastic, okay? So PC is inelastically demanded. Ultrabook is elastically demanded. A lot of no's, which appears to be correct answers, and there is yes, but you need to specify to which one. It's basically no and yes is half of the answer, basically. You have to say whether they should increase the price individually. So PC yes or no, Ultrabook yes or no, because you see that elasticities are different. These are two different cases. One is highly elastically demanded, one is very inelastically demanded. So PC, in a way, is a necessity for some people here, apparently. Or this PC provider, customers are inelastic demanding it. But an Ultrabook appears to be a luxury product because of the high demand elasticity. Price of Ultrabook, no. Don't raise it. Don't raise it, you mean. Let's look at it. Makes sense because it's elastic. The demand price of PC, yes, yes. This is the correct answer, guys. Yeah, PC is inelastically demanded. So raising it makes sense because people will still buy them because it's inelastically demanded, PC. Did you say just late? Yeah, no, I'm not discriminating. It's just, you know it better than men. That's the idea. But I'm not discriminating here. Or maybe my wife knows it better than me, so that's probably a better explanation. Right, so let's move on now. Interesting answers. Price elasticity of supply, as you can see, is similar formula here, but as I said, we don't study it in this lecture because it's the same concept as the demand case and just waste of time in a way. So please read it. It's just a couple of pages on your textbook about the quantity supplied and the elasticity of them. So it's just measures. So in this case, price elasticity of demand measures response of quantity supplied to price changes. And the response is now by the firms, yeah? Firms' response to price changes in the market. So I'm going to skip this. Important one that comes in your assessment is cross-price elasticity of demand. It measures how much the quantity demanded for one good changes or responds when the price of the other good changes, yeah? So here, as you can see, we have subscript A and subscript B. A standing for product A, B standing for product B. So EX is equal to percentage change in quantity demanded of a product A divided by price of product B. So moving on, we will always use arc cross elasticity. The same formula here. Quantity, so percentage change in quantity demanded of A over, now in this case, price of B. Yeah, keep in mind the percentage change in the price of B. So you can see that Apple and Samsung is always competing. So if Apple or iPhone prices go up by 100%, it's likely that we will switch to Samsung's, yeah, Samsung phones, yeah. So we can now measure the price elasticity of a cross price elasticity of, let's say, iPhones or just phones in this case. And we can also work out where the product is substitute or complement. Here's a nice rule for distinguishing between what the complements are, what the substitutes are. If let's say the cross price elasticity is greater than 0, notice that here the sign is important of the elasticity measure. If it's positive, an increase in price of iPhone, let's say, will lead to increase in the quantity demand of Samsung S9 or S10. Yeah? So there's a positive change in the quantity demand of S10 because iPhone XR is quite expensive now. The price rose by a higher magnitude. If the cross price elasticity is positive, these goods are usually, the two goods A and B are usually substitutes. Now, if the If the cross-price elasticity equal to 0, there is no relationship between the two goods. They are unrelated. Like the price of iPhone going up by so much doesn't change our demand for kebabs. If we especially like the kebabs, we just keep eating the same amount every week, yeah? But if the cross-price elasticity, EX, is negative, then this implies that the products A and B are complementary goods. We regularly buy them together, yeah? If we buy car, we always buy gasoline. Yeah, we don't buy gasoline, petroleum for other reasons in this country, right? Now, if the two products are considered good substitutes or complements, then they will have a cross-price elasticity of greater than 0.5 in absolute value, yeah? Whether it's negative or positive. They are good substitutes or good complements. So moving on now, here's an example that I'm going to skip because we only have 5 minutes to cover income elasticity, which is also an important measure before we move on. So think of this. In residential demand for electric energy with respect to price of gas energy was low, so 0.13. It's a positive value, however. It tells us that they are substitutes, right? But they are not good substitutes. Makes sense? Yeah. To keep the lights on, you need electricity these days. We don't have appliances that converts gas into electric light, for example. Yeah? I'll move on, but take a look at this, because there's another concept to cover. Or beef and pork, again, they are substitutes. Or chicken and beef. Again, these are substitutes. Pork, chicken, and beef, these are substitutes. That's why they have positive values. So we'll move on now. Now, income elasticity of demand now. This is a different story now. This is measuring by how much our quantity demanded of a product changes when our income changes. Yeah, it measures the sensitivity of demand to income changes. And notice this is a life cycle case here, or the life case. On the y-axis, we have quantity demanded here on the y-axis. On the x-axis, our income. Notice this. Pick a product. As our income rises from 0, as you're a student, you may earn no income. You may rely on your parents' savings or parents' income. But as you earn more income, you demand this product in high quantities. So there's a positively sloping line here showing your demand for a product. As your income rises, demand for that product goes up. Now, when you use this formula here to calculate the elasticity of income elasticity of demand of the product, you should get a value less than 1 but greater than 0 for normal goods. This good is a normal good. As your income rises, you consume more of it. At some point, you demand nothing. You become so rich that you don't eat that product at all. You don't consume that product. And as you become even richer, what happens is that you get a negative value. It becomes an inferior good for you. But this doesn't mean that it's a low quality. It just becomes an inferior good. It's just you demand less of it as you become richer. Think of baked beans. Right now you may consume them. You are a student. But as you become richer, your income rises. You try to reduce your consumption of baked beans, yeah, or sausages. In the morning you eat sausages for breakfast. As your income rises, you switch to something else. Better sausages maybe, a different category of sausages, or maybe some other good that you didn't consume before. But then demand for certain goods, like sweet corn, for example, in the morning you may consume them for your breakfast. It's a good alternative. Or you go to shopping and when your income is lower, you buy supermarket's own brand of rice. But then as you get richer and your income rises, what happens is that you buy a luxury rice. You switch from own brand to luxury. So these own brand goods are usually called inferior goods, not necessarily poor quality goods. Yeah, they are not necessarily. It's just inferior. There are also something called superior goods, where the demand actually jumps. The superior goods are usually luxuries, luxury products. As your income rises, you consume even more than what you could think of originally. Now, here is an example here. This last one. And we move on in 2 minutes. And this series also in your slides in the Korean Plus has, I think, 3 or 4 slides that are not essential, but reading them is useful. Yeah. So look at the cigarettes. Look at the cigarettes. Cigarettes have a negative elasticity. income elasticity. Although they are small, they have a negative income elasticity. So as you become richer, it's interesting, huh? Cigarettes become inferior good. Maybe you switch to cigars, right? Something like this makes them inferior, but I didn't expect them to do that. But it looks like this is empirical. Obviously, this is sample specific. So in the sample where this was studied, the people may have this sort of preferences for cigars, yeah? But look at the cars. They are in terms of price elasticity, they are, elastic, it makes sense. They are expensive things, high budget things, so we usually spend high amount of our budget on them, so price elastic. But in terms of income elasticity, they are super normal goods. Not only normal, but they are super normal goods. They have a larger than 1 value of income elasticity. So interesting, you may tend to buy luxury goods then, isn't it? Luxury cars. Anyway, look at this and reflect on your learning and see if you can apply the knowledge to interpret these results. Right, so we're done for today. And please read the chapter, attempt the quiz to reveal next week's content, and I'll hopefully see you all in the problem set or seminar classes.